The topic of the video is interaction picture in quantum mechanics. This is a video which should be watched after watching the videos on Schrodinger's picture and Heisenberg's picture. And it was developed by Mr. Dirac, so sometimes this interaction picture is even considered as Dirac's picture. And in this picture, both the state vectors of a system and the physical operators are assumed to evolve with time. And this picture is useful for solving for the state function of a system whose Hamiltonian can be written as a summation of two terms, the first being time independent h0 part, and then the second being the time dependent h1 part, as we're calling equation number 1. If psi t is the state function or the wave function of such a system, then the Schrodinger equation for that can be written as equation number 2. For a system, in the absence of these h1t, the time evolution operator can be written as u sub 0 hat t0 is equals to this quantity as that we had in Schrodinger's picture, and we call this equation number 3. By using this u, we define the wave function in interaction picture as psi sub I t as u inverse into psi t, and we call this equation number 4. When psi t was transformed to psi sub I t under this unitary transformation, then operators have to be transformed to this AIT by u0 inverse a into u0, and when we substitute for that u0, we'll get this for the operators in interaction picture, and we call this as equation number 5. And if we find the time derivative of ai from equation number 5, similar to the way that we did in Heisenberg's picture, if you do the math, then we get this as this commutator of AH and then the partial derivative of A in interaction picture. In equation number 5, if you take H0 instead of A, then we can try to write down its expression in interaction picture by using this on the right hand side. And since this h0 and then this exponential commute, we can write them h0 first and exponential later, and we can see that these two things will get cancelled, giving you to 1. And so we can say that h0 in interaction picture is also same as that in Schrodinger's picture. Similarly, we can write down this h sub I1, and then we get this expression from equation number 5, and the thing that we got here we are calling as equation number 7. Remember, we had this u with this exponential thing, and we are calling this equation number 3, and psi sub I as this one, and we're calling as equation number 4. So from those two equations, equations 3 and 4, we can actually write down psi t as this exponential factor and then psi sub I. And if we substitute this in equation number 2, which was Schrodinger's equation for psi t, and we can actually get this thing here. And then if you did the partial differentiation with respect to time for these two terms, we'll be getting this and this. And on the right hand side, if you substituted this ht is equals to h0 plus h1t, and then we'll get the second term on the left hand side and the first term on the right hand side being equal, they can get cancelled, giving rise to this fact that the first term on the left hand side is equals to the second term on the right hand side. And if you multiply this by exponential plus I by h cut into this factor, we'll get on the left hand side ih cut into dou by dou t of psi I is equals to this quantity on the right hand side. And then the thing that we had here from equation number 7, we can write this thing as s sub I, on top of it is 1 in the bracket and t psi I. So this equation number 6 is telling you how operators will be changing in interaction picture. And the last equation, which we may even say number 8, is telling you how the wave functions in interaction picture will evolve in time. That's it in this video. Thanks for watching.